Let's evaluate the line integral of y ds along a curve made of two joined pieces. A curved piece, then a straight piece. Picture the curve first. It starts at the origin, curves up and to the right like a sideways parabola, reaches a corner, then shoots straight up. Because there's a sharp corner, the curve is not smooth overall, so we must split it into separate smooth pieces and add the results. Step 1. Split the total integral into the integral over piece 1 plus the integral over piece 2. Step 2. Parameterize piece 1. Piece C1 is given by x equals t squared, y equals t, with t running from 0 to 1. Differentiating dx by dt equals 2t and dy by dt equals 1. Step 3. Build the arc length factor for piece 1. Take the square root of the quantity 2t squared plus 1 squared. This becomes the square root of 4 multiplied by t squared plus 1. Say this slowly. 4 multiplied by t squared plus 1. Never rush it together, since said quickly it can sound like 40 squared, and it is not that at all. It's simply 4 times t squared. Step 4. Set up the integral over piece 1 using this arc length factor. It is the integral from 0 to 1 of t multiplied by the square root of 4 times t squared plus 1 dt. Step 5. Integrate using a substitution. This gives the antiderivative 1/12 times the quantity 4 times t squared plus 1 raised to the 3/2 power. Step 6. Plug in the upper limit, t equals 1. That gives 1/12 times the quantity 4 times 1 plus 1, which is 5, raised to the 3/2 power. This works out to 1/12 times 5 root 5, which is 5 root 5 divided by 12. Step 7. Plug in the lower limit, t equals 0. That gives 1/12 times the quantity 4 times 0 plus 1, which is just 1, raised to the 3/2 power, which equals 1/12. Step 8. Subtract to get the result for piece 1. 5 root 5 over 12 minus 1/12 equals 5 root 5 minus 1 all over 12. Step 9. Now parameterize piece 2. Piece C2 is given by x equals 1, y equals t, with t running from 1 to 2. Differentiating dx by dt equals 0 and dy by dt equals 1. Step 10. Build the arc length factor for piece 2. The square root of 0 squared plus 1 squared is just the square root of 1, which equals 1. This piece's arc length factor simplifies beautifully to just 1. Step 11. Set up the integral over piece 2. It is the integral from 1 to 2 of t multiplied by 1 dt, which is simply the integral from 1 to 2 of t dt. Step 12. Integrate. This gives 1/2 times t squared, evaluated from 1 to 2. Step 13. Plug in the limits. 1/2 times 2 squared minus 1/2 times 1 squared equals 2 minus 1/2 equals 3/2. Step 14. Each piece has now been solved completely on its own. Piece 1 gives 5 root 5 minus 1 over 12. Piece 2 gives 3/2. Step 15. Add the two results together for the final answer. 5 root 5 minus 1 over 12 plus 3/2. Writing 3/2 as 18/12, so the fractions share a denominator, we get 5 root 5 minus 1 over 12 plus 18/12 equals 5 root 5 plus 17 all over 12. So the final answer is 5 root 5 plus 17 divided by 12.